Hey everybody. So we are getting into 9.5 today, part 2, which is going to be focusing on kites. All right, so go ahead and get this title here, get the definition of a kite, draw a picture here, and we'll get into it. All right, so focusing on kites. First, let's figure out what is a kite. Okay, it says a kite is a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. Okay, let's break that down real quick. So they're saying that it has two pairs of consecutive congruent sides. If you guys remember, consecutive means side by side. So if I'm looking at it, these sides here and here would be considered consecutive, and they are congruent to one another. Okay, over here as well, these sides would be considered consecutive to one another, and they're also congruent. Okay, so that's the first thing. But maybe the big thing to remember on this is that opposite sides of a kite are not congruent. If you guys take a look, these opposite sides, this one and this one, not congruent. Same thing over here. These opposite sides here and here, not congruent. Okay, so yeah, that is technically what makes something a kite. I'm sure you've heard of a kite before. You've probably flown one. All right, but technically this is what makes something considered a kite. All right, so yeah, today we've got some rules that apply to kites, and let's go ahead and take a look at them. All right, so the big thing for today is our 4 kite theorems. Okay, we got all 4 listed here. Go ahead and take a couple minutes and copy these, and then also draw yourself another kite because we're going to be putting these rules onto this kite as we go along. Okay, so take a few minutes, copy this. All right, so first thing here, it says if a quadrilateral is a kite, then its diagonals are perpendicular. All right, so let's go ahead and take a look at our picture here and let's add it. Okay, you guys remember the diagonals are these segments that cross through our shape here, and it's telling us that they're perpendicular. If you remember what that means, it means that the lines cross at a 90-degree right angle. So to show that, let's go ahead and put a right angle right here. All right, and one thing I just want to remind you of is this implies that all of these angles here are right angles. This is a right angle, so is this one, so is this one. We just don't draw all 4 of them because this mathematically we can show that all of them are right angles. Okay. Okay. Next thing, it says if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Okay, one pair of opposite angles are congruent. Let me point out what pair of angles that is. Okay, that would be this angle and this angle. Okay, those are the opposite angles that are congruent. Okay, and it's only this one pair. What that implies is that these opposite angles here and here are not congruent to one another. Okay, so what I like to think of is I like to think of these 2 angles as the wings of the kite, and you can think of it that way, that the wings are congruent. If you want to maybe put that in your notes here, one pair of opposite angles, you can put quote unquote the wings. If that helps you, that those are the angles that are congruent. Okay, next thing, it says if a quadrilateral is a kite, then one of the diagonals bisects the pair of non-congruent angles. Okay, so let's break that down real quick. First thing, non-congruent angles. Remember, that's these angles here. These are not congruent to one another. And what this is telling us is that this diagonal here is bisecting these angles. Okay, it's cutting them into congruent halves. Okay, so let's go ahead and show that. This angle here is being cut into 2 congruent halves. And over here, this one is also being cut into congruent halves. By the way, we should probably use 3 arcs on this one just to show that the measurements of these angles are going to be different from the measures of these angles. Okay, but really the big thing is realizing that this entire angle here is being cut in half. Okay, so just to kind of give you an idea, if we knew that this entire angle here was 60 degrees, we would know that both of these angles would be 30 degrees, right? It'd be cut into 2 congruent halves. Okay, so there's that one last one. It says if a quadrilateral is a kite, then exactly one diagonal bisects the other diagonal. All right, so taking a look at our 2 diagonals, the one that's being bisected, it's kind of obvious. It's going to be this one right here. It's being cut into 2 congruent halves. So let's go ahead and show that this half of this diagonal is congruent to this half. Okay, so this right here, this drawing of this kite that we drew, this is a really good thing to refer back to. This has all four of these new rules on it. This is at a glance the best thing to look at. Okay, so the rest of this lesson is just basically using these rules. So let's try them out. Okay, so on this one, we have an example with 4 questions here. So go ahead, take a minute, go ahead and copy the directions, get the 4 questions, and we're going to do these together. All right, so it says in kite A, B, C, D, just by the way, they're naming the kite. If you guys remember when you name something, they go around the figure. So, they're going A, B, C, D, just by the way. It's saying the measure of angle BAE is 28 degrees. Let's just stop right there and let's put that onto our picture. Okay, so angle BAE, a reminder on naming angles with 3 letters. This starts on the side length of the angle, goes around the angle to its other side length. So angle BAE is this angle right here. Okay, so they're telling us this right here is 28 degrees. Let's go ahead and put that into our picture. Okay, next thing, it's saying, and the measure of angle BCE is 57 degrees. Let's go ahead and put that on. So BCE, starting at B, going around C to E, we're talking about this angle right here. All right, so let's go ahead and show that this is 57 degrees. Okay, and then the last thing is find each measure. So it looks like on this one, we're just finding a bunch of angles. All right, here's what I'm going to do. Before even looking at this problem, there's a lot of information I can find. All right, let's do the obvious. Here's what we know about these angles here and here. They're being bisected. Okay, so that means if this angle is 28 degrees, we know this one's 28 degrees. Okay, and if we need to find the entire angle, we'll just add that together. Okay, same thing over here. If this is 57, this is also 57 degrees. And if we need to find this entire angle, we'll add those together. We'll see if they actually ask for that. Okay, so that right there, we can just get off the top of our head. Might as well add. Okay, but let's dig in and let's see what these are actually asking for. So take a look at number 1, the measure of angle ABE. All right, let's find it. A, starting at A, going around B to E. They're asking us to find this angle right here. Okay, well, here's something that we should probably add to our picture here. Since this thing is a kite, we know that these diagonals cross at 90-degree right angles. Let's go ahead and show that this is a 90-degree angle. Okay, which by the way means that this is also a 90-degree angle. Okay, so I'm going to put that in here. The reason why I'm doing that is because we're looking for this angle right here, angle ABE, right? Well, here's what I notice. This entire thing, let me highlight it. Let's see, what color do I want to use? I guess I'll use green. This triangle right here is just that. It's a triangle. And we know 2 of its angles, and we're looking for a missing angle. And we remember that a triangle's 3 angles add up to 180, right? So on this problem, that's all we would really need to do is take 180, if you want to show yourself in your notes, and subtract those 2 angles of this triangle. Okay, so I'm going to subtract 90, I'm going to subtract 28, and that's going to give me that missing angle. All right, just want to point out again, guys, since we're into a new semester here, if you if you do not have a calculator just yet, I highly recommend going on Amazon, going to Walmart, whatever, and buying a scientific calculator. As long as it has the sine, cosine, and tangent buttons on it, you'll be good to go. Okay, if you haven't bought one of those yet, you can. Also, you might want to call the school. The library might have some extra ones. Okay, but anyway, that gives me 62 degrees. Okay, so there's my answer. Okay, and whenever you guys get new information, I always recommend going back and putting it on your triangle. It might help us find another problem. Okay, let's keep moving. So measure of angle CBE. So let me highlight it. CBE is this angle right here. Okay, and yeah, we have enough information. If you guys notice, we have another right triangle right here. Okay, we know 2 of the angles of this triangle. This is 90, this is 57. If we subtract those from 180, we can get this missing angle that we're looking for. Okay, so this is a lot like the other problem. I'm going to take 180, I'm going to subtract this angle, 90, I'm going to subtract this one, 57, and that's going to give me my missing angle. All right, so you guys can see, as always, triangles always come back. It's literally the building blocks of geometry. Okay, so it looks like we're getting 33 degrees for the measure of this missing angle. Okay, and again, I'm going to put that up here on my picture. Maybe it'll help me find another problem. All right, keep moving. Down here, number 3, the measure of angle ABC. Okay, so let's find it. ABC, starting at A, going around B to C. That's this entire angle right here. And here's the good news. We already found the 2 parts of this angle. All we have to do is add them together. Okay, so again, just to show yourself in your notes what you're doing, we're just taking 62. We're going to add the other angle, 33, and that's going to give us the entire angle. It looks like we're going to be getting 95. Actually, since I'm kind of keeping my colors in order, let's do that. Okay, so yeah, 95 degrees, right? That would have maybe not been as obvious to us had we not written in our answers onto the shape. So again, always make sure you're doing that. Okay, last one here, the measure of angle ADC. Okay, let's find it. So starting at A, going around D to C, they're asking us to find the measure of this angle right here. Right? Well, here's the good news. If we remember, one of our rules for kites is that these opposite angles are congruent. Okay, we just figured out that this whole angle over here was 95 degrees. We know that this one over here is also going to be 95 degrees. Okay, so really no math required on that one. Okay, so those are really easy problems, just as long as you remember the rules for obviously kites, but also recalling the rules for triangles. All right. Just one other thing I want to point out. This is kind of by the way. We could have also figured out that this angle was 95 degrees right here. I just want to point out one thing. If we notice that this entire triangle right here, this is a triangle. All right, and we know 2 of its angles, 28 degrees and 57 degrees. If we subtracted those from 180, we would have figured out this missing angle. That would have been another way of doing it had we not known the measure of this angle. Okay, so there's a lot of different triangles that this thing breaks into. Okay, keep an eye out for them. All right, cool. So yeah, there's the only thing. Let's keep moving. Okay, so what I'm gonna have you guys do is go ahead and try a couple of these practice problems. On these ones, they're giving us the kites. They're asking us to find the measure of angle G on both kites. Okay, on number 1, that's going to be this angle right here, and on number 2, that's going to be this angle right here. All right. So what you're going to need to do is use your rules for kites. Here's my advice. Start with number 2. Okay, this is the easier of the 2 problems. And then after that, go and try out number 1 on your own. Okay, so go ahead, copy both of these, but start with number 2. Okay, so here's the first thing I'm hoping you notice on number 2. We know that the wings of this kite are congruent. All right, we know that if this is 110 degrees, this is 110 degrees. Okay, they didn't ask us for it, but we need to kind of work our way over to angle G. All right, here's the other thing we got to remember. A kite is a quadrilateral. And if you guys remember, the 4 angles of any quadrilateral add to 360 degrees. Okay, and if you want to remind yourself of that in your notes, it's not a bad idea. You can say 4 angles add to 360. Just like a nice little thing to remind yourself. Okay, if we have 3 of the angles of our quadrilateral, we can subtract those from 360 to get our missing angle. And that's exactly what we're going to do here. Okay, so I'm going to take 360 and I'm going to subtract these 3 angles, minus 110, minus 110, minus 60. Okay, and that's going to get us our missing angle here. So again, grabbing my calculator, let's see what happens. Okay, and I'm getting 80. Okay, so there it is. That's let's point out that the measure of angle G equals 80 degrees. Okay, and if you wanted to throw that up on your answer here, you could. Okay, but the big thing on this one obviously was first realizing, oh, opposite angles here are congruent. Okay, let's take a look at that in the context of number 1. Here's the problem on number 1. We do not know the opposite angle. We don't know angle E. If we did, we would get angle G immediately, right? Okay, so we got to figure out what's going on here. Okay, well, we just realized, okay, these are congruent. Okay, so here's kind of the rationale on this problem. If these are congruent, if I can figure out what these two angles add up to, I can then cut that number in half and I'll be able to get the measure of the two angles. Okay, so how do I figure out what these two angles add up to? Okay, well, again, I know all of these angles add to 360. If I subtract these two angles from 360, I'm going to get what these add up to, and then I can cut that number in half. Okay, so kind of another weird step, but yeah, let's go ahead and do it. So show on your notes, we're going to take 360 and subtract these two angles, 140. Okay, real quick, just so I don't mess up, I'm going to do it on my calculator. Okay, so I'm getting 220 degrees. Okay, and again, be careful, that's not the answer. That's what these add up to. So if these add up to 220, I can take that, cut it in half, and I can get what each measure is. And half of 220, you might be able to do it in your head, is going to be 110 degrees. Okay, so there's our answer right there. And I guess just to be specific, let's go ahead and point out the measure of angle G equals 110. Okay, and that wouldn't be a bad idea to just show yourself, okay, that means, this was 110, this is 110. Okay, so there's another thing to remember. Since kites are quadrilaterals, their angles still add to 360 degrees, and you can use that to find some missing angles. Okay, so yeah, those are a little tricky, but hopefully you at least understood, my process on those. All right, so from here, let's try an example that's asking us to use the Pythagorean theorem to find the sides of a kite. Okay, kind of a strange thing, but go ahead and copy this, and we're going to do this one together. Okay, so it's telling us to use the Pythagorean theorem. Let's just kind of first recall what the Pythagorean theorem is. If you guys remember, Pythagorean theorem, the way I taught it was c squared equals a squared plus b squared. All right, and if you remember, the time that we use the Pythagorean theorem is when we are looking for the missing side length of a right triangle. All right, so for example, if we had a right triangle like this, and we knew, two of the sides, say this was 6, this was 2, we could find this missing side here using the Pythagorean theorem. Okay, so how does that work in the context of a kite? Okay, well, here's what you might have already realized. Since these diagonals cross at a 90-degree right angle, this kite is broken into 4 different right angles. There's a right angle, there's a right angle, there's a right angle, and there's a right angle. Or I'm saying right angle, I should be saying right triangle. Okay, all 4 of those are right triangles. All right, and if we have 2 of the side lengths, we can find the missing side. All right, so let's focus on this one first, right here. All right, here's what I notice. We do have 2 of the side lengths of this missing, or of this right triangle. We can find this missing side. Okay, so what I'm going to do is I'm going to call this thing x, because that's usually my generic default variable. And I'm going to plug this stuff into the Pythagorean theorem. Okay, so let's go ahead and do it. Big thing to remember, guys. The reason why I teach the Pythagorean theorem this way is because, remember, C has to be the hypotenuse of the right triangle. And if you remember, the hypotenuse is always that side length opposite the right angle. This is the hypotenuse, which just so happens to be what we're looking for. Okay, so on this problem, I have to plug in x for C. Okay, A and B are the other 2 sides. Doesn't matter which you plug in for which. Normally, I make the smaller one A and the bigger one B. Okay, so there's my equation. I just need to simplify this thing a little bit and solve for x. So I'm going to keep x squared here for now. I got some math I can do over here. Okay, so let's see. 6 squared gives me a 36. 8 squared gives me a 64. And now I can add those together. So I'm getting x squared equals 36 plus 64 gives me 100. All right, and then last step to get rid of the power of 2. Remember, the opposite of squaring is square rooting. I have to do it to both sides. Okay, and this is where you might want to grab a calculator, or you might have memorized that the square root of 100 is a perfect square. It gives us a nice clean 10. Okay, cool. So there it is. We found the missing side of this triangle. If you want to erase x, we now know it is 10. All right, here's the good news. Well, here's, I guess, something to realize. It's asking us to find the sides of the kite. It wants us to find all 4 side lengths of this kite. But the good news is that these sides are congruent, right? These are those consecutive congruent sides. So if this is 10, we know this is 10. Okay? But we still need to find these 2 side lengths. So this is where let's focus on another right triangle. Okay? Here's another one right here. Okay, again, this is a right triangle. We know 2 of its side lengths. Okay, so this is one where I'm going to have you guys try this on your own. I'm going to just kind of split down here. Just like the last problem, you're going to use the Pythagorean theorem to find the missing side of this red right triangle. All right, just one thing to point out. This side length that we're missing, maybe we'll call it y because we already used x. Okay, if you want to use x again, that's fine with me, just as long as you understand what you're talking about. But just notice that this side length is opposite our right angle. This is going to be our hypotenuse. This is what you want to plug in for C. Okay, so I'm going to let you guys try this on your own. Go ahead and plug in the other side lengths for A and B and solve for the missing side length. See what you get. Okay, so on this, I would probably plug in 3 for A, 6 for B. Okay, so I'm getting y squared equals 3 squared is 9, 6 squared is 36. Okay, so I'm getting y squared equals 9 plus 36 gives me 45. All right, so last step, solving for y, getting rid of the squared by square rooting. Okay, we're getting y equals the square root of 45. Here's the thing, the square root of 45 is not a perfect square, but I do want your answers to be decimals if you don't have perfect squares. I think from now on, that's kind of what I'll want from you guys. Okay, so we don't need to simplify this. We just need to type it into a calculator. Okay, so grab a calculator. Make sure you know how to type this in. Okay, first you'll click the square root button on your calculator. If you have trouble with that, by the way, come into the Google Meet and talk with me because it depends on your calculator where that button is sometimes. Okay, but I'm going to do square root 45, and I'm getting 6.7082. It goes on forever. Okay, in this class, usually we're going to round to the nearest tenths. Okay, so the only question is does this 7 stay a 7 or does it round up to an 8? And it's all dependent on this number. If this number is a 5 or more, we would round this thing up to an 8, but it's not. It's less than 5, so we're going to leave this thing as a 7. Okay, so if we're rounding to the tenths, this would just be 6.7. Okay, so there are the missing sides of my triangle, 6.7, 6.7. Okay, so yeah, that's a good problem right there. Triangles, Pythagorean theorem, yep, we do not get rid of it in geometry, so just get used to it. Cool, so yeah, let's see. The last thing I want to point out is just kind of summing up this entire chapter. This is the last section in chapter 9, just so you know, and we've learned all of this. So if you guys remember, the entire section was on quadrilaterals. These are all 4-sided polygons, all right? The first thing we looked at was generic parallelograms, okay, opposite sides parallel. And then we looked at specific types of parallelograms. If you guys remember, it was, rhombuses, rectangles, and squares, where a square was both of these things, okay? And then our last lesson, we looked at things that weren't parallelograms. They were trapezoids, okay? And there was a specific type of trapezoid. Today, we looked at another type of quadrilateral, which, by the way, was not a parallelogram, and they were kites. Okay, so this is a nice visualization. You don't necessarily need to copy this. If you want to, you can, but it's just a nice way to give you like an overview of what you learned this entire chapter. Okay, and just by the way, these shapes off to the side, these are just quadrilaterals that don't fall into any categories. Yeah, they have 4 sides, but they're not any of these types. It's still possible for that to happen. All right, guys, yeah, that's our lesson today. If you have any questions, let me know in the Google Meet. I'll see you.